All right, this is exam 2 for fall 22, chapters 5, 6, and 7. This first one has roller coaster or cart has a speed of 8 meters per second at point A, so it has both kinetic energy and potential energy up here, and it also has kinetic energy because it's moving, plus some potential energy over here at point B, and I know that those two have to be equal. So for the first part, I can just apply that conservation of energy and say that the kinetic energy at point A plus the potential energy at point A has to equal to the kinetic energy at point B plus the potential energy at point B. So I can go ahead and put some of these values, or put this in. Now notice my masses all cancel. Good thing because I don't know my masses anyway. And now I can put in some values here. 1/2 of 8 meters per second squared plus 10 times HA, which was 10 meters, equals 1/2 of 6 meters per second squared plus 10 times HB. And I'm looking for HB, so that's 132 minus 18 uh, e divided by 10 equals HB. So I get that's equal to 11.4, or just 11 meters, keeping 2 sig figs. And then I want to know what is the velocity at point C. Well, notice here at point C that I only have kinetic energy. There is no potential energy. So I can do a similar, where I have kinetic energy at point A plus potential energy at point A is equal to the kinetic energy at point C. So that's going to be I can put in these values. Again, my masses cancel. Um, I'm just doing the same as what I had up here. That side's the same. Equals 1/2 of VC squared. And so this was 114, I think. 100 plus, oh, no, excuse me. This is 100 plus 32 times 2. Square root of that will be the answer for VC. So square root of 264, and that's equal to 16 meters per second. Make sure that makes sense. It should be faster than either one of these speeds. Yeah, that does make sense. So it's 16 meters per second. Consider this block that is initially at rest at the top of the inclined plane. If it's frictionless, what is the speed at the bottom? So this is very much like we did before. Here I have potential energy. Down here I have kinetic energy. I just set those equal to one another. Masses cancel. I get 10 times the height, which is 3 meters, equals 1/2 of the speed squared at the bottom. And I solve that for V. That's going to be the square root of 60, which is 7.7 meters per second. Now for part B, which is a little more complicated, first of all, I need to figure out what this distance is. Well, hold on. So it has potential energy here at the top, it has kinetic energy at the bottom, but now in part B it has a friction. So that frictional force is going to do work on that object, taking energy away from that object as it travels down the inclined plane. So I could look at it like this, that the potential energy minus the work that's lost by friction will equal to the kinetic energy at the bottom. So that's going to be mgh minus the frictional force times that distance is equal to 1/2 mv squared. So I need to find this distance here. So this is a special triangle, 3, 4, 5. If you're not sure how to do that, you can use the Pythagorean theorem to get that hypotenuse of that triangle. So I have 10 kilograms times the acceleration due to gravity times the height, which is 3, minus 2 newtons, it's 5 meters, equals 1/2 of 10 kilograms times v squared. And that's what I'm looking for. So I have 300 minus 10 divided by 5 and the square root of that. I get 7.6. So I lose a little bit of energy as I'm moving down that inclined plane so that it is going a little bit slower. All right, here I have this collision. This is an inelastic collision, so only momentum is conserved. I want to know the total momentum of the system. Well, I can just look at this part, the initial momentum. I know everything about that. That's going to be M1 V1 initial plus M2 V2 initial. Uh, that's going to be 1 kilogram times positive 4 meters per second. I'm doing the positive because you know it's to the right, plus 3 kilograms times positive 2 meters per second. And so that's equal to 4 plus 6, which is 10 kilogram meters per second. I'll put a little decimal place there so I know I have 2 sig figs. Now I want to know what is the final velocity. So after this collision, I know that P initial has to equal to P final. Momentum is always conserved in every collision in the universe. So I have this 10 kilogram meters per second is equal to whatever my final momentum is, which is going to be these two particles. That's going to be 1 kilogram times positive 1 meters per second plus 3 kilograms times V2 final. I'm solving for that V2F. So I have looks like V2F is equal to 10 minus 1, 9 divided by 3, or 3 meters per second. It is positive, and that is the answer, and that makes sense. All right, so this girl is doing around the world with a yo-yo. Yo-yo travels on a vertical circular path, shown as this figure. It's spinning at 3 radians per second. The yo-yo has a mass of 0.2 kilograms. The radius of the yo-yo's path is 0.5 meters. So first, I want to know the centripetal acceleration. That's going to be v squared over r. I don't give you v, though. I give you omega right here, so it's probably easier. Let's just write down everything I know to use that alternate form. Let's see. Omega is 3 radians per second. The radius is 0.5 meters. The mass is 0. I'm going to come back and put another sig fig there. And I think that's all that we have. All right, so now if I want to know the centripetal acceleration, I say v squared over r, or I could say omega squared r, and since I have omega, I'll go ahead and do that. So that's 3.0 squared times the radius, which is 0.5. That's equal to 4.5 meters per second squared. That's part A, and then for part B, what is the tension? Okay, so this was the more difficult question, although we did it in class. At the top of the yo-yo's path, the tension is down and the weight is downwards. So uh, the sum of those forces in the y direction is going to be negative Ft plus Fw. They're both in the negative direction, is equal to m times ac. But that's also in the negative direction. The centripetal acceleration is downward. So I can solve now for the tension in the string at the top. So that's going to be Ft plus Fw equals MAC, or Ft equals MAC minus Fw. So that's going to be zero point 0.2 kilograms times 4.5 meters per second squared minus the weight, which is 2 newtons. So let's see, I might not. Yeah, I'm going to have to make my weight less, or I will adjust this, but the numbers here are going to be different, and I'll give you all the right answer in there. So I'll have to adjust the numbers because as it works out here, the spin of it's not going fast enough for it to be actually in a circular path because I can see that I'm getting a tension that's actually going to be negative, and that's not appropriate for this. Okay, so I'll fix that. All right, let's move on to the multiple choice. Block has a mass of 4 kilograms, slide across the floor at 2 meters per second. How far does it travel after it encounters this kinetic friction? So it starts out with this kinetic energy. It loses some due to friction, and it's actually going to lose all of that energy. So I have 1/2 mv squared minus the frictional force times the distance that it travels. That's equal to 0. So that's 1/2 of 4 times the speed, which is 2 meters per second squared, minus the frictional force is going to be, remember friction is mu times the normal force, so that's 0.2 times the normal force, which is going to be 40 newtons. I just took this mass, the normal force is equal to the weight, which is equal to m times g. So since this is m times 10, that's 40. So that's the frictional force, mu times the normal force times the distance, which is what I'm looking for. That's equal to 0. So it's 2 times 4 is 8 minus 8 times d equals 0. So D is equal to 1. You drop a mass or box with a mass of 30 kilograms from a height of 1.2 meters. What is the velocity of the box when it reaches the ground? All right, so up here it has potential energy. Down here it has kinetic energy. I set those two equal to one another. The m's cancel out. That's going to be 10 times 1.2 equals 1/2 v squared. So v is equal to the square root of 24. It's 4.9. That's the right answer. Which of these is the basic SI unit for gravitational potential energy? Right, that formula there, that's kilograms, meters per second squared, and meters. So looks like that's the right answer. Here I have a block on a spring. It's traveling horizontally. It runs into a spring with a spring constant of 2 newtons per meter. The block comes to rest and compresses the spring. I want to know what is the displacement in the spring's compression. So over here, the block had kinetic energy. And now over here, when it's compressed this spring, it only has elastic potential energy. So that kinetic energy all becomes elastic potential energy. And I'm looking for x. I can solve that for x. That's the mass. That's the velocity. K is 2.0. And then I have x squared. It's 1/16. All right, so A is the right answer. Consider the spring in the previous problem. What is the force of the spring when the compression of the spring is 0.5 meters? So what if x is equal to 0.5 meters? Well, I know K, that's equal to 2 newtons per meter. So I just multiply those two. The magnitude of the force is just equal to K times X, and that's all I'm asking for. That's going to be 0.5 times 2, or 1 newton. Oh, here I have a block on an inclined plane. Frictional force acting on the block is 10 newtons. What is the speed of the block when it reaches the bottom of the incline? Oh goodness, this is almost identical. Let's see, I might change this problem just a bit, or I might just let y'all do it twice. That's fine. So just like we did before, the kinetic energy at the top minus the work done by friction is equal to the kinetic energy at the bottom. Excuse me, the potential energy at the top is equal to the kinetic energy at the bottom. So okay, let's see. Sorry about that. So the potential energy at the top, that's mgh minus the work that's being done by friction, that's F times D equals the kinetic energy at the bottom, that's 1/2 mv squared. I've already said that this distance is 5 meters, so we have 20 times g, which is 10 times 3, minus the frictional force, which is 10 times 5 equals 1/2 of the mass, which is 20 times v squared. I'm going to erase this 5 just to get it out of the way. And now solve for v. 20, 200, 600, 550 equals 10 v squared. And so v is equal to the square root of 55. I think that's 7.7. Or 7.4, excuse me. So B is the right answer for number 6. Person applies a force of 6 newtons to this block at an angle of 60 degrees to move at a distance of 4 meters. Frictional force of 2 newtons acts on the block. What is the total work? So I want to know the total work done by both of these forces. Now the work will equal to the sum of those forces. The work done by F is going to be 6 newtons times 4 meters times cosine of 60, which is 12 joules. And then the work done by the frictional force is going to be negative 2 newtons times 4 meters. That's equal to negative 8 joules. So I have a total of 12 minus 8 are 4 joules for number 7. Okay, box slides towards you and you stop it. Which of these statements is true? Okay, you did negative work. That is true because as it slides towards you, you're here. You're applying a force in this direction, but the displacement is in this direction. So you're doing negative work on the box. The work you did is equal to the work of the frictional force. Okay, not necessarily. No reason those would be true. The gravitational force did work on the box? No, because the displacement is, horizontal, but the gravitational force is vertical. And you did positive force, positive work on the box. No, you actually did negative work, so E is the right answer. 1 kilogram block is traveling to the right at 3 meters per second. It collides with a stationary 2 kilogram block. All right, so let's just draw a picture here to help us see it. So this is the 2 kilogram block. And then the 2 kilogram block now has a speed of 1 meter per second. And I want to know now what is the velocity of the 1 kilogram block. So we don't know if it's to the left or the right, so I'm not going to draw anything saying that. But I do know that the momentum here, Pi, has to equal the momentum here. So Pi is equal to Pf. That's going to be 1 times 3, 1 kilogram times 3 meters per second, has to equal to 1 kilogram times its velocity, v1f I'll call it, plus 2 times 1. Um, so that gives me v1f of 1 meter per second. Here's another collision. A railroad car has a mass of 2,000 kilograms and is traveling at a speed of 4 meters per second. It runs into a stationary railroad car with a mass of 6,000 kilograms. So I have these two. This one's moving in this direction. It's 2,000. This one's stationary. And then they connect and move off at the same speed. So this is v1i. This is the 6,000 kilogram. V2i is equal to 0. Here I have an 8,000 kilogram combined mass, and I want to know what is VF. So I say this is equal to 4 meters per second. So I have the initial momentum equals the final momentum. That is 2,000 times 4 meters per second. The other car is not moving, so it has no momentum, is equal to 8,000 times VF. So that's going to be C, solving that for VF. Object with a mass of 3 kilograms accelerates from 8 to 12 meters per second in 6 seconds. What force has caused this acceleration? So remember Newton's second law is ma, or m delta v over delta t. This is how Newton expressed Newton's second law in terms of momentum, or dp dt. So I have 3 kilograms times delta V. Delta V is equal to VF minus VI. That's going to be 12 minus 8. Divided by delta T, which is 6 seconds. 12 divided by 6 is 2 newtons. Car traveling at 10 meters per second crashes into a wall and it occurs in 10.10 seconds and the car rebounds. So this car is traveling initially in this direction and then, it rebounds and the final velocity is in that direction. So VI is equal to 10, VF is equal to -2. So my delta V is equal to -2 minus 10, which is -12 meters per second. So that's my change in velocity, and I want to know what is the force. So that's going to be delta P over delta T, or M delta V over delta T, which is going to be 1,000 kilograms times delta V, which is -12. I'm just looking for the magnitude. In fact, I didn't say it wasn't moving to the left or the right, but so I'm just going to get rid of that negative. It doesn't really, not important for me. And then over delta T, which is 0.1 seconds. So it's 12,000 over zero point 0.1. That's 120,000. Which of these statements is true for inelastic? Okay, momentum is conserved. Yes, that's not true. That is true, that energy is lost to those things, and that's not true. So it's like A. Uranium nucleus is rest, undergoes fission. Which of these statements is true? They have the same momentum. Yes. Here, Pi is equal to 0. P1F then has to equal to P2F, but in the opposite directions. A lighter fragment has the greater speed. Yes, since P is equal to M times V, if M is small, V is big. Heavier fragment has more momentum. No, that would be opposite of number 1. And the lighter fragment accelerates faster than the heavier fragment. Yeah, uh, because V goes up at a faster rate, and so yeah, because F is equal to dp dt, or M delta V over delta T. And because the mass is so small, this is really big. I mean, that's just an application of Newton's second law. So this is the right answer. Which of these is represented by the white section of the figure? So notice here, if I draw my coordinate system now, this angle would be pi over 2. So this is half that, which is D. If it rotates in the plane, which point will have the bigger angular velocity? Oh, this is a rigid object, so they're all going to have the same angular velocity. Object is at rest, that means omega naught is equal to 0. It accelerates at 3 revolutions per second squared until it reaches a speed of omega final equals 6 revolutions per second. What is the angular displacement equal to? And notice I don't have to change the SI units because everything's in revolutions already, and so I can just keep it in that. Now theta I know is equal to omega naught t plus 1/2 alpha t squared. Ooh, but I don't know t. But I have this other information, so I can say that omega equals omega naught plus alpha t. That is 6 equals to 0 plus 3 times t, so t is equal to 2 seconds. Now I can come back up here and find out what theta is. That goes to 0 because omega naught is equal to 0, so it's going to be 1/2 of alpha, or 3 revolutions per second squared, times 2 seconds squared, so that's equal to 6 revolutions. A majorette twirls a baton once every half second. What is the angular velocity of the baton? So omega is equal to delta theta over delta t. And so my delta theta is going to be 1 revolution, or I want it in radians, 2 pi radians over every half second. So that's going to be 4 pi radians per second. An object at rest begins to rotate with a constant angular acceleration. If this object rotates through an angle theta in time t, through what angle did it rotate in the time half t? So theta is equal to omega naught t plus 1/2 alpha t squared. Omega naught is 0. right? Because it's at rest, that goes away. If I have half of my t right here, that means because it's squared, I'm going to have a quarter theta. Let's see, I think there was another question right here. Give me just a second, I'll find it. Yeah, there was a 20th question here. So a boy swings a 2 kilogram stone in a horizontal circle where the radius is 2 meters. The string breaks when the stone rotates at 2 radians per second. What tension in the string will cause it to break? I'm gonna have to go back over here. I'm sorry. Um, so I have this boy swinging a stone in a horizontal circle like this, and when he has it rotating at 2 radians per second, that means that the centripetal force on that is equal to m omega squared r. The mass of the stone is 2 kilograms. Omega is 2 radians per second. That's squared times the radius is 2 meters. I got happy with the 2's there, didn't I? 2 times 4 times 2. That's 16 newtons. That is the centripetal force uh, that it has at that point, and that is the tension when it breaks. And so the answer then is A.